So we're under a high wind warning, you may know. But I think they're only talking about 40 miles an hour. So it's only, you know, tropical storm strength. So what questions do you have? I've seen an amazing variety of strange behaviors on this lab because it's a complicated dynamic system. You have the second order motor dynamics. You've got the dynamics of the sensor circuit, which is mostly a delay, a pure delay, right? Because you have to wait for the next blade crossing. So that adds a speed-dependent phase shift on the input. Then you've got the control dynamics that you're building. And then in terms of measurement, you have a couple of single-pole filters to reconstruct waveforms for the control signal and for the RPM. So there's a lot going on. There's lots of pieces, which is, well, I said it probably had to be done mostly in lab. Well, what questions do we have at this point? Yes?
So PID, like the output is like a control value?
PID output is a yeah, I'll float.
So how do you recommend converting that to a duty cycle?
Well, as I've said before, the basic duty cycle from 0% to 100% depends on your timer interval. So you're going to set up some timer, timer 2 or timer 3, your choice. You're going to set up timer 2 or timer 3 to some interval which is fixed. So the number of counts might be set to 46,738, and that is the range you have to scale to. So if you are calculating some control factor, some control C of t, then you have to scale it so whatever the max is here scales to 46,738. Yes?
Yes, I'm wondering if the max, you just said to like 0x f. So like, yeah,
Why would that be the max? Why would 65,000 be the max?
well,
It's going to depend on how you scale RPM. Are you going to use RPM or RPS or some other weird unit? Are you doing any sort of floating point or fixed point offsets? But basically, you're going to say that C of t can't be much bigger than the maximum error times the static gain. P, right? The maximum error would be... Oh, come on. What's the maximum possible RPM error you can have? 3,000. You multiply that P times that, that's going to be the maximum, approximately the maximum value of your function. There's going to be some derivative terms in there, but they're probably small. And some integral terms, but they're probably small. So let's make it downgraded to say 90% of it's going to be P times the error. And so that's how you're going to scale it.
How might you convert the infrared output into the actual RPM band?
So the infrared output is a square wave, probably 1 pulse per fan blade, right? So you want to get RPM from that? So this is T of 1 blade, right? So 7 times TB is going to be 1 revolution. So 1 over 7 times TB is going to be a speed. Yeah?
So you can't do that on the oscilloscope. You just do that on the
I'm asking you to do this conversion in software
Yeah.
and convert that RPM, the value you put on the TFT, 2200, whatever it is, you then need to copy into a PWM channel and output to the scope. You're going to use the same timer, so you're going to have to scale that to 46,738, if that's what you choose for some unknown reason for the timer period. So you're just adding. One of the errors I've seen a lot today, and it really surprised me. And that is that my output compare code initialized two separate output compare units, and it appears as if one of them is correct to use for PWM, one is not correct to use for PWM. It appears that people rolled the dice and chose one. So let's see if I can find that code again. So if we go to the output compare example code, down near the bottom of it someplace we're setting up a timer, of course, with the generate period, which is a constant, and then we're opening two output compare units, one of which does a PWM with the fault pin disabled, and the other one does a continuous pulse. This won't work, folks. You have to use the PWM mode. I tend to write examples for output for I/O that are as general as possible, because that means I can write fewer examples, which makes the web pages easier to maintain. They are not meant to be template codes for a lab. So you have to actually read them and find out what piece of it is useful in a given lab. Is there any question on that? If you set the system up in OC PWM fault pin disabled mode, then if this is the timer period from timer reset to 0 to the period time, then a PWM value of 0 will be either one count or no counts, I can't quite remember, but it'll be a very narrow pulse, and a PWM of 100% will be effectively on all the time. If you use the other mode, if you use the continuous pulse mode, then you get some very odd results with these at the edges of at the boundary conditions of 0% and 100%. Basically, it generates a 50% duty cycle square wave at half the frequency, which you do not want. A couple of people have had trouble with their fan walking around the tabletop. We have tape. And while it is never acceptable to put tape on a printed circuit board, it is certain, because of ESD considerations, it is perfectly acceptable to tape the fan to the desktop. there's a, I don't know if I've already said this in the class or not. 10 or so years ago, somebody did the experiment of putting Scotch tape onto a piece of glass in a high vacuum and then using a manipulator to pull the tape off of the glass. And when they did that, they generated soft X-rays. So 10 to 15 kilovolt X-rays. And that's not good for your circuitry. So the fault pin, if you read the documentation, you will find that the fault pin is an input which allows the microcontroller to detect that the motor has failed and turns off the PWM. So let's say that you had a current monitoring circuit on the motor, and the current suddenly goes to some gigantic value, so you're suggesting that the motor is seized up. Then you might want to turn off the voltage to it. So this is a fault detection to avoid destruction of hardware. We're not using it. Seems unlikely that you're going to demolish anything with a 100th horsepower fan. But in any case, there's no measuring circuitry that you could feed back. So you would, if you had a circuit that would indicate a motor failure, you'd input it to the fault pin. What else? So any questions about the Lab 4 grading? Went through last time. Lab 4 is all good. Yeah?
I know that on the web page it says exactly which plots you want. There's like 2 that you state that should be in the lab report. Maybe you can just elaborate and make that clear. Which ones you want to see it.
Okay. Which plots do we want to see? Well, first of all, more plots is better plots. What does it say? Screen dumps of typical two-trace motor control and actual RPM, including acceleration and deceleration steps. So, for instance, so you might put the oscilloscope on slow scan, maybe 500 milliseconds per division. You have one person ready to start and stop the oscilloscope trace, and the other person poised at the keyboard to change the speed commands. And as the trace goes across, you step from 500 to 1,000, and C of t then does something like this, and the RPM hopefully does something like this. And then a little while later, perhaps on the same trace, so this is 500 to 1,000, maybe a little bit later in the place if the person is a very quick typist, you might go 1,000 back down to 500. You watch this decay away, the C of t decay away, and you watch the motor speed decay back down. That is the minimum you need to have. You might want to expand out this portion in detail to get the 0 to 80% or 0 to 90% rise time, to document that, since that's one of the things you're going to be graded on. You might want to do 0 to 90% on the falling phase. You might want to have an example of what happens when you turn the proportional gain up too high and the system starts to oscillate. You could imagine all kinds of interesting dynamic features that you document. If you look at the scope and say, I wonder why that happened, take a picture of it. What sort of 0 to 90 rise times have people been seeing? Two or 3 seconds, really? The best I've seen is 100 milliseconds. For a step from 500 to 1,000, the fastest I've seen is about 0.1 to 0.2 seconds, someplace in there. 240 milliseconds, yeah, that sounds like about the right range. 2 seconds sounds slow.
That was a little bit generous. I remember some else things so
Okay. All right. What's the side play over here? What's up? What? There was some comment from over here. What was it? Okay. So,
Didn't you say that whenever you set the arc here back to 500, that we should have, because of that error, we should turn control instantly to 0?
actually, yes, this should drop instantly to 0, but because of the time constant of your measuring circuit, it'll look like 1/10 of a second. And by the way, because you're using a tau of 0.1 for the low pass for the measuring circuit, you're never going to see a rise of much faster than 0.1 second. That's actually, if you look at a square wave, the time constant of the circuit corresponds to 0 to what? Percent. Zero to 63%. 1 minus 1 over e, right? So one time constant would really be down here, so you can't get that time any shorter than 0.1. So this has got to be above 0.1. Oh, that suggests maybe you should change the time constant down to 50 milliseconds and just see what happens. Only do that. Only do that if you have nothing better to do in your life. Since I specified 0.1, leave it there unless you are really stupefied by all of your courses and have nothing left to do in them. Does that ever happen? Okay. So, what else on lab 4? It's a complicated lab. There's lots of moving parts. So, I think Friday. It's beginning to run together. Friday, I was talking a little bit about generation of sounds. And so I'll take that up again and again, unless there's more questions on Lab 4 or on final project. Yes.
So, how do you recommend start the motor initially?
How to do what?
How to just start the motor?
Well, how to start the motor? Well, in main, you could set the pulse width modulator to 50%, which will, or in other words, when you initialize the OCX unit that you're using for the pulse width modulator, set the initial width to half of the period or 3/4 of the period. That'll guarantee that the motor turns on unconditionally. Another failure I saw was before the first capture occurs, corresponding to one blade crossing time, people were doing a divide in a high-speed thread that was resulting in a zero period dividing by zero and failing the thread. So you can calculate that if you set up the motor to full speed, that you should get a zero crossing, you should get a fan blade crossing in about 3 milliseconds or so, 2.5 milliseconds. So you could put in the control thread, you could yield for 5 milliseconds before you go into the while measurement loop, and allow the first zero crossing to occur, the first blade crossing to occur, the first 2 blade crossings to occur, before you try and control this thing. So you turn on the motor to full speed or 3/4 speed. You wait for a couple of crossing times, then you start running the control algorithm. Now, probably a lot of people just haven't had that problem, it's just worked. And probably that's because it takes a little while for the threader to get set up. Yes? You can initialize it to 0 RPM, but then you get no you get no speed measurement because you have no blade crossings. And as long as you handle that condition properly, that's fine. If it works, it works. That's fine. Did I see another question on your face? No. Okay. Sometimes I can read questions off of eyebrow shape. What else? So let's go back and talk a little bit about synthesis, sine wave or music synthesis, note synthesis, sound synthesis. We want to produce an envelope. So you pluck a guitar string, you get a fast attack, you get a slow decay of the amplitude of the sound, and for a lot of processes, these are approximately exponential. If you're using any kind of resonant system, like a string or an air column in a horn, or anything that stores a lot of energy, in other words, it has a high Q, it has a low loss per cycle, you're going to get something like an exponential rise and exponential fall, with perhaps a sustain here before the exponential fall starts. So we want to be able to always modify a sound that we're making, a tone, whatever it is, to produce a realistic envelope. If we're using physical synthesis, where we're actually computing the differential equations of the string, this envelope happens automatically because we're calculating the physics. But if we're faking it with a additive synthesis scheme or a FM synthesis scheme, where we're just generating a waveform and then playing with it until it sounds like something reasonable, then we have to also fake the rise and fall time. And what I talked about last time was that for a envelope that looks like some initial amplitude times an exponential decay multiplied by an exponential rise, that you don't want to calculate all these exponentials. You have to keep track of absolute time. That's not so bad after a start event. But calculating e to the minus x is an expensive calculation. And by playing with the differential equation for a little while, you find that you can calculate incrementally. If you know the last value of the amplitude, you can calculate the next value of the amplitude just by multiplying by a number. So you take r times y times n minus 1, you get the new sample. You step through in time, say once per interrupt service routine, and you generate an exponential decay for the cost of 1 multiply. So that's pretty efficient. Today I was on the way to work, though. It takes me 40 minutes to get to work, so it's long enough to think about obscure things and drive off the road. But so I got to thinking, why not use direct digital synthesis? It works for sine waves. Why shouldn't it work for an exponential? And what I said last time was, well, you wouldn't want to table drive this because you'd have to have lots of tables for different time constants. But that's not true. No more than it's true that you have to have a lot of sine wave tables for different frequencies. You just have to step through the table at a different rate. So I think it should be possible, I'm pretty sure, in fact, that using a multiply here is a waste of time. In fact, you should just be doing a memory operation and do a table lookup. Now there's some details here that are a little tricky, but I think are handleable. By the way, this falls under the category of code that is not written can do anything. Right. So you have an exponential fall starting at some finite value 1 and going on forever. Oh, that's not good for a table. So you have to truncate the table someplace. How far out should you trunk it? How many time constants out should you truncate it? 4? 5? What's e to the minus 5? You got it. Who's got Google open? 0, 0. So it's less than a percent, but not much less than a percent. So 5 time constants is probably enough. And here, out of 5 time constants, we're going to have 0.0067. How many dBs down from 1 is that? That's a little over 40 dBs down. Right? It's actually almost 46 dBs down or so. Can you, if this were starting at 80 dBs, would you hear that? Do you know what the definition of 0 dBs is? That's the sound you can just barely hear. This is 10 dBs, folks. But it's amplified. So a whisper is going to be around 10 dBs. Right? You start at 80 dBs, you go out 40 dBs, it's still going to be 40 dBs. You're going to hear it. What you're going to hear is when it goes from there to exactly 0 because you hit the end of the table. Oh, that's going to, it's jarring, right? What do you do? I like it. Subtract the 0.067. Say, we're going to compute this out. We're going to subtract the 0.067. It will therefore go identically to 0 at 5 time constants. And yes, it'll start a little bit. It'll be 1 minus 0.0067. You won't even hear that difference. Fine. Works. Okay. How many points should be in this table per time constant? So let's say that you want to have that the biggest step you have in the table is 1% of the amplitude. So that means that every time you change the amplitude of the signal, it'll be about well, no more than fraction of a dB. How many points per time constant do you need? Oh, well, I guess we need to know the slope of the exponential function, right? What's the slope of the exponential function at 1? At 0? Oh, what I'm really asking you to do is to recall the Taylor expansion of an exponential, which you probably all have at the tip of your tongue, right? X plus x squared plus x cubed plus x to the 4th. Lead term is x. Slope is therefore minus 1. And so the biggest slope is going to be at the beginning of the curve, and it's going to be minus 1. And that says that if we want to have no more than a 1% change in the amplitude between steps, that we need about 100 steps per time constant. So this will be about 100 steps. If we go all the way out here, then that's 500 steps. That's okay. That's an okay sized table. Not too small, not too big. It's, decent, reasonable. So one last thing we need to do is then say, so when we do the direct digital synthesis, we're going to, of course, fractionally step through this table. So we may step very slowly through the table if the time constant is long. And we may step very quickly through the table, maybe skipping every other point if the time constant is very short. So what should the time constant, the absolute value of this time constant be in seconds for a good synthesis? Good meaning it sounds decent. What's your guess? I don't actually know the number. I don't know the answer to this. I haven't even tried this experiment. Would somebody like to guess what value it should be? 10 seconds? Doubtful. Too long. Do you know of any instrument that has a time constant of decay of 10 seconds? Not even a high Q, low frequency thing like a bassoon or a tuba has a decay time of 10 seconds, I don't think. Even the highest Q structure I've ever tested on campus, which is the west turret of Course and Mud, has a time constant of only 4 seconds or so. It's great to go over there and do ping sounds. Go the loud whistle sounds in the turret over there. It's awesome. You can hear it for like 15 seconds. Do you go around testing the Q of structures? I was afraid of that. All right, so I do. Yeah, I tend to tap stuff. You may see me do that. I tap stuff to try and get some idea of the resonant quality of it and what it does. I particularly like tapping on fire extinguishers. They have a pretty good cue. So, what would you guess the time constant should be for some sort of psychophysically good time?
Like
3/4 to a second, so around a say 0.5 to 1 second. I think that's reasonable. I think it could be anywhere, perhaps even down as low as 1/10 of a second, but I'm not sure about that. I think much faster than that, and you're not going to perceive any steps at all. I think that's going to be dominated by other features like spectral spreading of the sine wave as you make the pulses shorter. But I really don't know. It'd be an interesting thing to try. So I think you can table drive this, drop this down to 0 multiplies, which significantly speeds up the synthesis, which means you can make more complicated sounds. All right, so much for hallucinations on the way to work. I think what I want to talk about next, so we talked a little bit about FM, this idea that you take one direct digital synthesis unit and you generate a modulating function for a second DDS, and the result, I played some of those sounds, didn't I? Did I not? Kind of weird stuff, yeah. And I think what I'll do next, if there's no other suggestion, yes?
I just have a question about general final project, like schedule.
Yeah?
What's the high-level overview of what lab you're coming into, and like what to expect, and what you suggest you should start doing over that?
What you should start doing over the next week is very preliminary testing for the first steps of whatever you're going to build. So if you're going to build something mechanical, start doing the mechanical stuff. If you're going to start doing something musical, start figuring out what synthesis method you're going to use and start programming up an exponential decay table. If you're going to do capacitive touch, figure out how to use the CTMU, the charge time measurement unit, which is built in and underlies this particular chip has built-in capacitance touch sensor. Woo! 18 channels. Woo! But you got to figure out how to use it because it's not exactly straightforward. Once we stop having lecture, which will probably happen in a week or maybe a little more, then you will have no other assignment in this course whatsoever except to be in lab. That means, since it's a 4-credit course, I can expect you in lab 12 hours a week. You're going to need it. That means we have to come up with 12 times 100 seat hours. Has sort of an odd sound to it, doesn't it? Seat hours per week in the lab, and we will. So you need to rearrange your life with the idea that you're going to be spending a lot of time in lab that you would otherwise either spend doing homework or lecture. Do not assume that the deadline is 5 weeks away and therefore you need to do nothing next week. First of all, the TAs are going to be asking for weekly progress reports from everybody. And secondly, you don't want to go without sleep for a week and a half at the end of November. Now, Thanksgiving break cuts into the work schedule at an inconvenient time. That's why I think we ought to move to Canadian Thanksgiving and do it last month. But that isn't going to happen. So what's going to happen is that you get back from Thanksgiving, and that week is the demo week. Starting on Tuesday that you get back. Well, listen carefully. There is an optional extension into study break. And I'll figure out the timing. But there will be an optional extension into study break. I can never remember now with the new schedule how long that is, but I believe it's 2.5 days. And so the project is due during your last lab period. But there is an optional extension into study week. Once you demo the project, the only thing left to do is to hand in the report on the day that the university registrar deems appropriate for this class slot. There is an alternative to the final schedule, which is the project report schedule. And every class has a designated time and day that their final projects, if any, are due. Do you happen to have that up? Is that what? That's yeah.
It's December 10th at 11:30 a.m.
11:30 a.m. Awesome. Isn't that 11:30 a.m. is like late evening, right? Of the day before. I might extend that just a little bit. So so it's December 10th is when the project report is due. What is the... And I'll verify that, make sure that you're not spoofing me. Actually is that the registrar doesn't change their mind. When is the last day of class? It's the 4th? Friday the 4th? So study is then 5th, 6th, 7th, 8th, and then final start on the 9th? Is that correct? Okay, so the tentative optional extension, got that? Is you will sign up for a demo slot on one of those 3 days. It will be a half-hour demo slot sometime during the day between 8 a.m. and 4:30 p.m. And then the final project report will be due the 10th. Which sadly is the next day after that, but that's life. Right? You don't have to do everything at the last minute. The web page. The web page is the report. There is no other report besides the web page that you are going to send to us. The web page will consist of precisely an HTML file and any other files you want to associate with it, images, code, whatever. And you have to follow the submission directions that are given at the bottom of the assignment, because We're using a Unix server. If you use Windows extensions that are randomly upper and lower case, it won't work. You have to match the capitalization style in the hyperlink with the actual name of the file so that PNG is not equal to PNG. It has to be, the zip file has to be named in a certain way with your net IDs so I can identify who's who. And you'd think, oh, well, that's BS. Why does he need that? Why can't it have a descriptive title? Because I keep these things around. The way I search for you 5 years from now when you ask for a recommendation is by the net ID that you use for the zip file. So, follow the directions. Sadly, it's the people who come to class are the ones that almost always follow the directions. So I'm talking to the wrong group. But do it. Just follow the directions. It should be fine. We need you to submit that. I probably noon. Truthfully, that day, the 10th, I'll probably extend it to 4 p.m. on the 10th. Unless somebody has a problem. Does anybody have a problem with this schedule? Does anybody have a problem with the optional extension?
So the optional extension is like we use max.
You will not be it's an optional extension. It is a no penalty optional extension. Do you understand why I'm using those words? Who wants to explain to me why I'm using those words?
So that it's optional in the sense that if you need it, you can take it, but it's preferred to get checked off as early as possible. You don't have upwards of 50.
So yes, I mean, yeah, you're putting it from my point of view, which the earlier the better, right? Oh, by the way, the bonus for early submission is based upon the date of your lab period, not the optional extension. So if you have a Tuesday lab, you have to you have to demo your final project the Tuesday before Thanksgiving to get a 1-week early bonus. The reason for the wording is the university says nothing can be due during study break. Does this follow the spirit? I'm not sure. It follows the letter. That's why I'm asking. Does anybody have a problem with it? Gives you more time to work on it. But it's also going to eat your study break. Or at least some of it. Yes? It is if you have partners in different lab sections, it is due on the earlier of the days. That shouldn't matter. Everybody's got the same amount of time. It's 5 weeks away. Oh, it's forever. I got 40 deadlines before then. If you have a problem with this, email me. Yes? Louder, please. The first day I am going to order parts is next Monday. 0800, they come in after that, they don't get ordered for a week. I need to do that because I have to get that out of the way early in the morning before I go down and sit in the lab for the rest of the day. Yes? Maximum $20. Excuse me, what I can afford to spend is about $1,000 a year on this. So that's a maximum of about 20 per group for all 5 weeks. So you get your total orders, we have to be less than $20. And I don't prioritize, I don't guess. When you hit the 20 order limit, if it's in the middle of an order, I cut off everything below that line and I do not order it. I want the part numbers, the supplier, in simple, stupid text in the mail file. I have to enter this through the most contorted interface you ever saw, called Kawali. Have you seen this? Some of you have. Oh my God. Anyways, so anything other than plain text slows me down and I won't do it. So just plain text.